When adding a second panel board to an existing electrical service, it's crucial to adhere to the National Electrical Code (NEC) to ensure safety and compliance. The primary concern is not exceeding the capacity of the existing service. NEC Section 225.30 A1 states that the total load of both the original and the added panel board must not exceed the total capacity of the existing service. Furthermore, NEC Section 225.30 A2 mandates that the added panel board must be protected by an overcurrent device, such as a circuit breaker, rated no greater than the ampacity of the feeder supplying it. To determine the maximum permissible size for the second panel board, follow these steps. Firstly, calculate the existing load. This involves adding up the ampacities of all circuits currently connected to the original panel board. It is essential to determine the actual load rather than simply adding up the breaker sizes. Secondly, subtract the existing load from the server's capacity. Determine the capacity of the existing service in amps, and then subtract the calculated existing load from this value. This difference represents the remaining capacity available for the second panel board. Thirdly, consider voltage drop. Voltage drop occurs as electricity travels through wires. An excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 215.2 A2 recommends a maximum of 3% voltage drop for branch circuits. You'll need to account for voltage drop when selecting the appropriate wire size for the feeder supplying the second panel board. This will impact the allowable ampacity of that feeder. Fourthly, use NEC Table 310.15 B16. This table provides ampacities for various wire sizes based on their insulation type and ambient temperature. By referring to this table, you can determine the maximum size of the feeder and the corresponding overcurrent device rating based on the total load and allowed voltage drop. Fifthly, choose the correct panel board size. Select a second panel board that is rated for the ampacity of the feeder and has sufficient space for the anticipated load. It's better to choose a panel board with more spaces than you currently need, as future expansion may require additional circuits. Here is an example. Let's say the existing service capacity is 150 amps and the existing load is 120 amps. This leaves a remaining capacity of 30 amps. If the feeder ampacity, after considering voltage drop, is determined to be 25 amps, then the second panel board size should not exceed 25 amps. In addition to the primary sections already mentioned, there are other NEC sections that may have a bearing on the installation of a second panel board. NEC Section 225.40 addresses the location of panel boards, which must be readily accessible and not located in hazardous locations. NEC Section 225.40 B covers the enclosure or room for panel boards, requiring sufficient working space around the panel board for safe operation and maintenance. NEC Section 225.40 C discusses the grouping of panel boards which may be required in certain installations for convenience and safety. NEC Section 240.15 B deals with grounding and bonding, which are essential for preventing electrical shock hazards. The panel board must be properly grounded and bonded to the grounding electrode system. NEC Section 240.83 specifies overcurrent protection requirements for equipment. It's important to ensure that the overcurrent devices protecting the panel board and its circuits are properly sized and rated for the equipment they serve. To elaborate on calculating the existing load in the original panel, it's not simply about adding up the breaker sizes. Each circuit may not be loaded to its full breaker capacity continuously. The NEC permits demand factors to be applied in certain situations, especially in residential settings. These demand factors allow you to account for the fact that not all appliances and lights will be operating simultaneously at their maximum load. Consult NEC Article 220 for detailed information on calculating branch circuit, feeder, and service loads, including the application of demand factors. Consider the type of loads connected to each circuit. Continuous loads, defined as loads that operate for 3 hours or more continuously. must be factored at 125% of their maximum current demand. This requirement is outlined in NEC Section 210.20 and 215.3. Examples of continuous loads include lighting in commercial spaces, electric vehicle charging, and certain types of heating equipment. Non-continuous loads can be calculated at 100% of their maximum current demand. When determining the appropriate wire size for the feeder supplying the second panel board, you must consider not only the ampacity of the wire, but also its ability to handle the available fault current. Fault current is the amount of current that would flow in the event of a short circuit or ground fault. The wire must have a sufficient interrupting rating to safely withstand the fault current until the overcurrent device operates. Consult NEC Section 110.9 and 110.10 for requirements related to interrupting rating and fault current protection. Voltage drop is a critical factor in electrical system design. Excessive voltage drop can lead to reduced performance of electrical equipment, overheating of conductors, and even equipment failure. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you'll need to consider the length of the wire, its ampacity, and the current flowing through it. Several online voltage drop calculators are available to simplify this calculation. When selecting the overcurrent device for the feeder supplying the second panel board, it's essential to choose a device with an appropriate interrupting rating. The interrupting rating is the maximum fault current that the device can safely interrupt. The available fault current at the panel board must be less than the interrupting rating of the overcurrent device. Overcurrent devices are available with various interrupting ratings, typically ranging from 10,000 amps to 200,000 amps or more. NEC Section 110.9 requires that equipment intended to interrupt current at fault levels must have an interrupting rating sufficient for the available fault current at its supply terminals. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent device to quickly trip and clear the fault. Bonding ensures that all metallic parts of the electrical system are electrically connected, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding in Article 250. The grounding electrode system must be properly installed and connected to the panel board and other metallic parts of the electrical system. Surge protection is another important consideration for electrical systems. Surges are transient overvoltage events that can damage sensitive electronic equipment. Surge protective devices, SPDs, are designed to protect equipment from surges by diverting excess voltage to ground. SPD can be installed at the service entrance, panel boards, and individual equipment locations. NEC Section 230.67 requires surge protection for dwelling units. Arc fault circuit interrupters, SIs, are a type of overcurrent device that provides enhanced protection against arc faults. Arc faults are dangerous electrical faults that can cause fires. SIs are designed to detect arc faults and quickly interrupt the circuit, preventing a fire from starting. The NEC requires SIs in many branch circuits, including those serving bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, GFCIs, are another type of overcurrent device that provides protection against electric shock. GFCIs are designed to detect ground faults, which occur when current leaks from a circuit to ground. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing electric shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. When installing a second panel board, it's important to consider the working space requirements around the panel board. The NEC requires sufficient working space to allow electricians to safely operate and maintain the panel board. The working space must be clear of obstructions and must have adequate lighting. Refer to NEC Section 110.26 for detailed working space requirements. Labeling is essential for electrical safety and troubleshooting. All circuits in the panel board must be clearly labeled to indicate the equipment they serve. The labeling must be durable and easily readable. NEC Section 408.4 requires that each circuit breaker or switch be legibly marked to indicate its purpose. Additionally, a directory must be provided that lists the circuits and their corresponding loads. Proper wire management is essential for a neat and organized panel board installation. Wires should be neatly bundled and secured to prevent them from becoming tangled or damaged. Wire connectors must be properly tightened to ensure a secure electrical connection. A well-organized panel board makes it easier to troubleshoot problems and perform maintenance. Before energizing the new panel board, it's essential to perform a thorough inspection to ensure that all connections are properly made and that the installation complies with all applicable codes and standards. Check for loose connections, damaged wires, and improper grounding. Use a multimeter to verify that the voltage and current are within acceptable limits. Documentation is an important part of any electrical installation. Keep a record of the panel board installation, including the wiring diagram, load calculations, and inspection results. This documentation can be helpful for future maintenance and troubleshooting. Consider future expansion when designing the electrical system. It's often more cost-effective to install a larger panel board than is currently needed to accommodate future loads. This can save you the expense of having to upgrade the panel board later on. When selecting a panel board, choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories. All listed panel boards have been tested and certified to meet safety standards. Ensure that the panel board is properly installed according to the manufacturer's instructions. The installation instructions provide important information about mounting, wiring, and grounding. If you are not qualified to perform electrical work, it's best to hire a licensed electrician. Electrical work can be dangerous, and it's important to have it done by someone who is trained and experienced. Always follow safe electrical practices when working on electrical systems. Wear appropriate personal protective equipment, such as safety glasses and gloves. Disconnect power before working on any electrical circuits. Use a voltage tester to verify that the power is off. If you are unsure about any aspect of the electrical work, consult a qualified electrician.